Hi, welcome to our second video of the reverse engineering tutorial. Going back from what we have done in our previous part, we created two surfaces. One was the bottom revolved surface and the other one was the top revolved surface. One other thing which I want to show is the deviation analyzer. The deviation option for any surface displays how the surface approximates the real one, and it gives a full color plot of the results. We can create a tolerance, which is our acceptance area, and we can either display the whole object or only the selection triangles where we have worked on. So I'm happy with this one for this revolved surface. Then I will investigate the other one. Click on the deviation. The software instantly shows the displacement of the mesh from the surface. In our case, we're happy with this. So now we need to move to the next step, which is to model the wing. The wing is represented as a freeform surface, so we'll use the patch command. Of course, we need to select the area and adjusting the sensitivity with the magic one, which will be the part. We're happy with this. So now we select the patch command. Patch command creates a surface which is similar to the one in Rhino, but the difference is that it tries to find the best option in a way so it approximates the surface in the best way. Look at the deviation. We can see how it is displaced from the surface. The user can provide a target tolerance. This is where the process should stop. And also he can control the result intent, how the surface will approximate the scan data. There are three choices. One is whether to keep the smoother surface but compromise the displacement, or it can make a much better approximation, which will increase the number of UV points but will get as close as possible to the result. In my case, I just used the balanced approach and it gives a quite good result. The other way which we can play with is how the patch, the result, is oriented in space. In current example, it makes a fit, finds the minimum plane, and it adjusts the direction of the patch to approximate the surface in this way. But we can make it working in a way so it's mostly parallel to the growth axis. This is also important when we do the modeling later, so we know how this extends and how well it intersects the other surfaces while we do the trimming. I'm happy with this result, so I'll move to the back part of the wing by creating a new shape, select the magic one. I will unselect some of the top area here. I will add extra selections, all ready to go, and I call the patch command. Patch command is really time saver, it's fast and quick. I'm happy with these results, or I will just adjust the world axis. The reason I did this to get a much bigger surface for the trimming purposes later. Okay, now we're ready with this part also, but I will need another surface here in order to trim the actual wing. In this particular case, I know that the way I can do this is by creating another revolved surface, and I will pick the top of the wing by the selection using the line tool. I need to create the profile of the revolved surface. Okay, we don't need this. Select it extra. Again, I will model this surface with a revolve option, setting the direction in z-axis, passing through the origin. So now it's important to understand why the section works, because if we try to do this in Rhino with a single profile section, we won't be able to get the actual profile. But because here we can add many sections, they add up and define actual profile. I will rebuild this, and if I take a look at the sketch, this is what we get. I will delete this and create a line here. We'll create a line here, and we'll model this with the freeform curve again. Always we can set the tolerance option on and off. I will work with the 50 microns accuracy. As always, I do the line longer so it can intersect with the others. Modify the line. Here we can either create a fillet or we can just make it sharp. I will extend this. You see the snapping tool helps us to get the right position. Taking back to the shape to see if it helps. If it's okay, yes, it goes out enough and it's extended here. So we have this nice revolved surface. I think we have everything we need to start creating the actual model in Rhino. I will create all the surfaces in Rhino. You can either click one by one and create in Rhino, or you can create all the surfaces with single button click. So for now we don't need any more mesh to surface, so the rest will be actually done in Rhino. How we'll do this, we'll start trimming all the surfaces using the Rhino tools and create the final result. Thank you for watching. We'll see you in the next video.